Hi everyone, my name is Sam and welcome to my Next Gen AI Guy YouTube channel. In this video, we're going to learn that how to utilize AI to create a fashion style assistant. This project I have built with the help of Gemini, Chroma database and OpenClip embedding model. I will going to show you the demo plus code how to build such kind of project. From that you will get an idea how to build any project with the help of Gemini 1.5 Pro, Chroma database and OpenClip embedding model. So before jumping to the code part, let me just give you the demo of this project, what exactly it is and what I have built. This is the AI, the fashion styling assistant. This AI is going to help us in a fashion styling. In this project we have two options. You can do the search with the help of images as well as your prompt. Whatever kind of cloth you wanted to wear, accordingly based on the prompt, or if you have an image, based on that image you can retype the similar image. So this is the whole project which I have built. Here I have uploaded a blue suit .jpg image. So based on that it has retrieved the image. So that is the blue plus white and dark blue tie. So that image it has retrieved, and the AI is going to recommend you brief description it has generated based on this image. So what exactly it is, how should you wear it, like shirt, tie, shoes and pocket scare, watch, belt, everything it has recommended you the style how you should wear that one. So based on that Gemini AI has given this recommendation. Based on the image it has retrieved the three image, and with respect to each image it has generated the recommendation. So first image is here and description, second image and third image and its description. So based on the images it has recommended this particular styling. Now we will going to see based on the prompt does it able to do it or not. Red top. Okay, based on the query it has retrieved the images. So here is a red top, this one is also wearing a red top, it is still running, and AI will going to recommend you the whole styling, that what should you wear, how you should wear perfectly, what jewelry, belts, bags, everything it will going to recommend you. It has recommended so many things. Over here you can see that embrace the casual vibe, elevate for a evening, or accessories are key, means what are the accessories you should wear with that cloth. It has recommended. The recommendation is quite good, as you are able to see over here that what time you should wear, what are the jewelries and other things you can wear with that particular cloth. So that is the AI which we have built. Both ways we have implemented. You can do the retrieve based on the images, or you can do retrieve based on the query. One more example I can show you. In that one we will try something different, white shoot. So let me delete this one and click on the generate styling. So this is the image of white shoot. So based on that it has retrieved the white suit image. Before going to the code part, let me show you the flowchart, how exactly it works. First of all, we have an image dataset. So in that case, I have loaded the image dataset from the Hugging Face. So that dataset I have loaded from the Hugging Face. Then we have applied the embedding model. Embedding model allows us to convert that images into a vectors, which is a numerical representation of that image. So that vectors we will going to store into the vector database. So whenever you will ask a query or put any image, that image or query will be converted with the help of embedding model, and that converted vectors we will going to do the similarity search with the stored data which is stored in this vector database, and then we will going to retrieve the similar images with respect to particular query. After that retrieved data we will going to send to the vision model, which is in our case is a Gemini 1.5 Pro. In case if you wanted to use a ChatGPT 4.0, that one also you can do. So that images we will going to feed into the vision model. That vision model is going to assist us in a fashion styling, and that images plus the recommendation we will going to see in that UI. Now let's move to the coding part. I will going to explain you everything easily and in depthly. So over here we are able to see that we have a two folder. which is data and vector database. First we have loaded our data set from the Hugging Face, then we are storing in this folder. And next one is the vector database. That data images is converted into a vectors, and then we are storing in this vector database folder, which is ChromaDB. And here we have a .env file to store our credential. In this .env file, you just need to save Gemini 1.5 Pro API key over here. Here we have a load data module. With the help of this module, we will going to load our images and we will going to store that images into this data folder. Next is the main.py file, where we have written our main code to run this Fashion AI assistant. After that, we are having requirement.txt file. So in that one, we are having whatever the packages is required to run this project, that one we have written in this requirement.txt file. After that, we have a stored embed.py file, which is responsible to load the all images from this folder and do embedding and store into this vector database. So let's start first with the load data module. First we are importing load dataset from dataset. So this load dataset allows us to load the data from the Hugging Face. After that, we are importing OS operating system, and here we have initiated our load dataset, and in that one we have given the path of the dataset. I can show you also. So for that, you need to go to the Hugging Face, and over here you just need to. So this is the fashion dataset we are utilizing. So that path I have given in our code. So we are loading the dataset from the Hugging Face. After that, we have given the dataset folder from where we wanted to save our images. And this is the os.makeDirs, which allows us to create directories. In that one, we have given the dataset folder name and exist OK equal to true. After that, we have created one function. This function allows us to save that images one by one into this data folder. So here we have passed the dataset, which is over here. This will going to load the all images, and here we have given the dataset folder, which is data and number of images. In that Hugging Face, we are able to see that we have a 45.6k rows, means that many number of images we are having. To build this project, I am just using only 1000. In case if you wanted to use more than 1000, you can change the number as much as you need. So one by one, we are iterating from the training part. We are taking the images one by one, and we are saving that image into the dataset folder, which is data over here, and we are giving the name. As you can see over here, that image and the first will be the 0. So 0 plus 1 is a 1. So _1 dot png. So that was our image name. So here that function we are calling over here by providing the dataset. Dataset is over here, and the dataset folder name and number of images, which is 1000. After that, we are just printing that save the first 1000, means saving documents is completed in that particular folder name. After saving all that images into the data folder, we will move forward to a store embed.py file. So this modules allows us to, first we will going to load the images from this data folder, and then we will going to do embedding. After that embedding, we will going to store in this vector database. Here we are importing the ChromaDB, which allows us to store the data into a vector format. And after that, we are importing the OpenClip embedding function from the chroma.utils.embedding function. This is the OpenClip embedding model, which allows us to convert that images into a vector format. So next we are importing a image loader, which allows us to load that images from the given folder. Next we are having a OS, which is operating system. Here we have given the dataset folder where our images is stored. This ChromaDB allows us to store that data locally, means you will be able to store the data into the local disk. How we will going to do that? With the help of persist client. So in that one, we need to pass that where you wanted to store the data. So that path we have provided over here. After that, we have initiated our image loader, which we have imported over here, and the OpenClip embedding model, which we have imported over here. Next, we are initiating our chroma client .get or create collection. So over here, we have given our collection name, which is images. Whatever name you wanted to give, you can give it over here. Then we have given our embedding model, which is clip, and that data loader, which is image loader, which allows us to load the images from the given path. And this is the empty list we have created for IDs or URI, means uniform resource identifier. So that will be going to be our path name. Here what we are doing, iterating one by one with the help of for loop. First what we are taking index number and the file name from that dataset folder, and dataset folder is data. So one by one it will going to load that images from there. It will going to give the index number and that file name which is stored in this dataset folder. Here we have given the if file name ends with .png, so we are only going to load the png images. Here we are just joining that dataset folder and the file name. So file name is going to be this and dataset folder name is this, so it will be data/image_1.png. so that will be file path. Now that file path will be our URIs, uniform resource identifier, and the IDs is going to be our index number. So that index number first we are converting into the string format, and then we are appending into given data into that list, means at the last it will going to add, so that all file name, IDs and URIs will be stored in that list. After that we are just adding in this image_vdb, which is over here. We have initiated our Chroma client, and in that one we are adding all the IDs and URIs. After that we are just printing image stored to the vector database. So that was the way to load the data from that folder and do the embedding. After doing embedding we can store that into a vector database. So in case if you have a personal data set, you don't need to use this load data function because the data is already in your particular folder. So that path you just need to provide in this store embed.py file. So here you can pass that path, and it will going to load all the documents, do embedding and store into the vector database. Next and main important is the main.py file. Here we are running all those things. We are taking the query, then we are doing the retrieval from the vector database, and then we are sending that to the vision model to give us a recommendation to assist us in a fashion styling, and then we are showing into the UI. For the UI I have used the Streamlit. So Streamlit allows us to create a UI. So first we are importing the Streamlit, next we are importing the NumPy to handle arrays. After that we are importing the pill.images to read the images with the help of this pill. After that we are importing IO, which is input output. Here is we are importing request to read any URL or get any URL data from the web. After that we are importing the generative AI. This allows us to get the vision model Gemini 1.5 Pro from the Google. That's why we are importing a generative AI. After that we are importing OpenClip embedding function, which I have already told you, and here we are importing the image loader. So after that we are importing the Chroma database to connect with that vector database. Here we are importing load.env from a .env file, which allows us to load the credential from this .env file. And here we are importing OS, operating system. After that we are importing the warning. Sometimes what happens when you run the project, it will give some unnecessary warning. If you wanted to ignore that, you can write the warning stored filter warning, single quoted or double quoted. You can write ignore. Here we have initiated our load_.env file. Here we are importing our API key. So that API key name you have to write in the .env file. That variable name should be same as you have written in the .env file, and os.getEnv file allows us to, with respect to that variable, it will going to extract the value. So that will be stored in this API. After that we are feeding that API key into the genai.configure. So we have passed that API key over here. So this is the format function. This functions allows us to format the image input. So after retrieving the images from the vector database, we are extracting the URI, means uniform resource identifier. That is a path of that images where it has stored. Here we have taken the image path 1, image path 2, and we are appending into that image path list. So after that we are returning that image path. Next function is the open image function, which allows us to open that images. So here we have given the several ways. If the image is URL, then you can apply the request.get. After that we are opening with the help of pill.image. In case if it is in an array, image data is in an array format, then it will going to read. So this is the way to open that image. In case of it is not able to read, then it will going to throw the exception as we have written over here. And this is the st.title. This is the title which is the fashion styling assistant. And after that we have written the enter your styling query and get image based recommendation. This is just for a UI. And here we have created a upload button. In that one you are able to upload JPG, JPEG or PNG file. So this is the type of images you are able to upload. And here we are having the text input. Means we have two ways to do that. Either you can retrieve the images by uploading the images in that given format, or you can do the retrieval based on this query also. So this is the, if you will click on the st dot button, means if you will going to click on the generate, this is the button which we have given over here. After clicking, so it will going to run the project. So to run that, first we have initiated our chroma client. In that chroma db.persist client functions, which allows us to connect with that vector database which is stored over here, and that image loader which allows us to load, and the clip embedding model, that all we will going to feed into that get or create collection. So the collection name is the image, and the embedding model which we have given over here, data loader is the image loader. So that is the database we have connected, and we're storing that connection into this image underscore bdb. So this is the variable. This allows us to connect with this vector database. Here we are having two ways. Either you can upload your image and based on that you can retrieve, or if you have query, so that one also you can do. So either you can do with the query, or you can do with the help of by uploading the images. If the uploaded file is not none, means if you have uploaded the images, first it will going to open with the help of pil.image.open. After reading that image, we are converting with the help of numpy.array. We are converting that images into array format. That uploaded images we will going to feed into the our image vdb, which is connection we have made over here. So this is the image vector database, and that one is dot query. So here we have feeded the query underscore images. This chroma database support 4 types of query. Either you can do with the help of query embedding. If you have an embedding of the particular image, based on that you can also search. 4 ways we have to do the search or retrieve the images from the vector database: from the embedding, from the text, from the images, or if you have a unique resource identifier path, so that id you can pass over there. Based on that you can retrieve. So as we have uploaded the image, so we wanted to retrieve the data based from the query images, so that's why we have choose the query images. So in that query images we are giving the uploaded image which is converted into numpy array. So that images we are feeding over here. After that we are including the data and number of result, means how many images you wanted to retrieve from the database. That one you can write over here. In this one we have given the 3. By default it will be 10. Here we have just streamlit.subheader we have provide. All the retrieved images will be stored in this retrieve underscore image variable. In that one we are enumerating. This will give us the index and the data. So one by one, whatever images you have retrieved, that images open image function I have shown you, that is the open image function, and that functions allows us to open that image which is retrieved and store in this variable. So this functions allows us to open that image, and that image we are going to show into the UI. So streamlit.image, and we have passed that image over here, and caption we have provided retrieve image and the index number. That index plus 1 we have given. So as many number of images it is going to be, that caption we have given over here. So after that we have initiated our Gen AI model, which is the model name which we have given over here is a Gemini 1.5 Pro. This is the vision model, and in that one we have given the prompt. So you are a professional fashion and styling assistant. This prompt allows us to instruct to the model what you should do, what you are. That instruction we will going to give to that vision model, and based on the instruction it will going to work. So we have given the prompt over here, and that prompt we have passing into that model, which model we have initiated over here, model.generate content. In that one we are passing the prompt, and we are passing the image, which is one by one we are retrieving over here. That open image we will pass over here, and that response we will going to show into the UI st.write response.text. So whatever recommendation it has generated, that we will going to show below that image. So in case if any error occur, we will going to throw the exception. Now let's see, that was the part of if you have uploaded the image. In case if you wanted to retrieve based on the query, so that we have written over here. So first we have created a query db. So this is the function which will take query and the result. Means query what kind of fashion you are looking for, result means how many images you wanted to retrieve. So that one will going to pass that image underscore vdb. I have shown you that we have initiated over here. In case of uploaded file, we have passed the query images, and here we are passing the query text and number of result you want to, means the number of images you wanted to retrieve, and what you wanted to include, means we want the URI's uniform resource identifier and the distance, so that we wanted to be included. After that we are calling that function over here by passing the query and number of result, and here we have just formatting that image. That function I have already shown you. That function is written over here. So what it will going to do, whatever images we have retrieved from the vector database, from that one we are extracting the path of that images. So that function is written over here. So that images path will be stored in this variable, and one by one we are opening over here. So from that path we are opening with the help of pill.image.open. So we are storing into the sample file 1, sample file 2. As we have given the number of result, we want the 2 images. So that 2 images will be stored into this sample file 1 and sample file 2. And those images we are showing on the UI with the help of st.image. The sample file caption we have given over here. After that we have initiated the model, and in that model we have given the Gemini 1.5 Pro. The model which we are using. So here we have given the prompt. In this prompt we are adding the query as well as, so the model will get a better understanding of that what exactly they are looking for, and we will pass the model that whole prompt and the images. So both images we are passing in a one go. Based on that it will going to generate the content, and that will be stored into this response variable, and that response variable we will going to write on that UI. So response.txt, that we will going to show over there. So that's how this main.py file work. How to run this project? It's quite simple. First of all, create an environment. You can create a virtual environment or conda environment, whatever you want. So to create a conda environment, you can write conda create -n, the env name like my env, and then Python version you can write 3.11, and you can hit the button and it will going to create. And to activate it, just you need to write conda activate the env name, which was my env. After that you can hit and it will going to activate the environment. So in our case we have already activated, so our environment is already activated, which is ai.env. Now first we have to install all the dependency which we want to run this project, which is written over requirement.txt. To install the all dependency, you need to write pip install -r requirement.txt and hit the enter button. And hit the enter button, it will going to install all the dependency which is written in this requirement.txt file. After installing all the dependency, first you need to run this python load.py file, which will going to load the all images from the Hugging Face and store into this data folder. And next you have to run the python store underscore embed.py file, which allows us to load the images from this folder and do embedding, and then we will store in this vector database. After running this, then you can finally run the whole application by writing the streamlit run main.py file. After writing, it will give you the particular URL, and on that URL you can click, it will going to open that web application. So that was the way to build AI the fashion styling assistant. So I hope you got an understanding of that, how to write the code or how to build such kind of project. Based on that idea you can implement in your own project as well as. So that's all from my side. I hope you enjoyed this project. I hope you learned something new today. Please like and subscribe for more such videos. Thank you.